Cool. Hi, hello, everybody. Welcome to another Metagov seminar. It's nice to be back here. It's nice to see so many people here today. I think right now we've got 30 people, still people trickling in. It's lovely. Lots of new faces, lots of fresh faces, lots of old faces. So good to see so many people here for the first time. Today's seminar is going to be on a project called Koi Pond. We're going to be discussing KOIs, knowledge organization infrastructure, and how they integrate into Metagov's ecosystem. Today's presenters are going to include Brooke and Coco, Luke Miller, Rennie, American Zargham, and I'm basically working from Koi during this presentation. Like I work at Metagov currently as the community manager with Val, names also changing, Senti, and I'm ready. Like I'm using Koi. I'm trying to get as many people to use it and become malleable and agentic with it. So yeah, cool. Okay, good morning, welcome everyone. I'm gonna be the host for the session. We're gonna do a 30-minute sort of presentation by the 4 presenters today. They're going to go quick. I'm going to keep things moving fast. I'm going to be in the chat. I'm going to be answering questions. I'm going to be working with people. If you have questions as we're going, post them. And then after they present for 30 minutes, we're going to do 30 minutes of recorded discussion. I'm going to try to collate and compress all the questions I get. I might even throw them into Koi and see what Koi says, and then pose them to our panel of presenters today. And then we're going to do 30 minutes of unrecorded after seminar discussion where we can follow up and really kind of do a deep dive into the tank. So with that, who am I passing off to first? I think it's Ellie, right?
Yep.
Cool. Ellie, take it away.
Sure. So KOI stands for Knowledge Organization Infrastructure. And if Senti is KOI today, then Senti is going to be hallucinating and saying some pretty strange things, just to warn you, for reasons that we will get to. It's still a very early stage project.
It's true.
So, yeah. Many months ago, in a GovBase call, Josh Chan was asking the question, would adding an LLM to our Slack, as in Metagov Slack, make it easier to stay across our organization, to onboard people, to encounter Metagov's rules, those kinds of questions. And many people over many months joined the GovBase call to discuss. And thanks to all of them for their inputs. My own personal interest was whether an LLM with access to a collectively agreed or bounded set of knowledge objects could be used by an ethnographer or anyone else seeking to understand the dynamics of a group. And around those early days, Michael Zargham, who you're about to hear from, came into the discussion to suggest that we use the KOI architecture, which had been developed by BlockScience, and he will describe it better, and connect that to an LLM as one of the many possible KOI services that we could use and develop, which we will. So the question of what would a KOI provide that other approaches using LLMs would not, for me, the answer was the ability to govern how knowledge is accessed and treated. And typically a firm will have its system designed so that knowledge processes conform to a system's instructions. But with a KOI, the ontology of the system is local to the organization and it can be emergent and evolving. So our interest at Metagov is how a group can co-create that ontology, how the ontology of that system changes through our community interactions and decision-making, and also how we might be able to connect our knowledge to the knowledge of other groups through these systems. So I'm going to hand over to Zargham right now.
Awesome, thank you. So Ellie and I are co-PIs on the KOI project at Metagov with a kind of split between social and technical focus, but we've collaborated for many years. So this has been a really fun project to bring our works together. In particular, I want to emphasize the fact that the technology that we're kind of experimenting here is not an LLM technology. It's a technology for managing information. And the first version of the software that we have iterated on was actually really about indexing internal knowledge at BlockScience, where we do a lot of engineering and kind of translation work, where we're dealing with requirements, designs, algorithmic policies, rules, all sorts of different knowledge objects, ranging from just messages to documents to formal requirements to simulations to data from like operational systems. And so we found ourselves, managing lots of different kinds of information and needing to remain across it. And so we started building out some systems. And then we went from indexing an internal search, slapped on an LLM as a sort of UX affordance, realized it fundamentally altered the user experience patterns, behavior of the team members, and then have since continued to iterate on our internal technology as think of it as an organizational infrastructure, just a tool to make what we're already doing work better, with, as a result of our research, a strong requirement that we weren't assuming a kind of absolute ground truth, kind of overly rigid ontology, specifically because we work across a lot of fields, and actually a rigid ontology created lots of issues. It made it very difficult for us to understand or find things. And so we iterated on our tooling, we shared our technical implementation with the Metagov team, and we started this process of instantiating another version of the same core, let's say, principles and technology with a different ontology and with a different group of people responsible for what it knows and how it expresses what it knows. And for me, at least, this is a really exciting and compelling direction of research, because we want to move away from models where there's one size fits all technology or sort of overly rigid right answers to systems that can have kind of local sense making and even communication across regions. Longest view here is ways in which these distinct systems can talk to each other. If you're interested in the specifics of the technical motivation in architecture, I would check out the A Language for Knowledge Networks piece. But today, rather than talk too much about the way we imagined it, we're going to focus on letting Luke demonstrate how it works today and the development work ongoing. But I believe before we get to that, I need to pass to Brooke to give you an important ethics-related public service announcement.
Yeah, thanks, Zargham. Hi, my name is Brooke. I am a PhD candidate at RMIT University in Melbourne, and I've been engaged with the Metagov community for about 1.5 years now. As part of my PhD research, I'll be leading an ethnographic study that documents how Metagov navigates the adoption, integration, and maintenance of its COI. And the research findings are intended to be used to provide an empirical feedback to refine the project's digital governance models. So throughout the COI project, I'll be focusing on digital governance tools and the collective governance frameworks that our community implements to better align our COI with Metagov's values and strategic objectives. So because my research will examine how social dynamics and digital governance tools mutually interact and shape one another, ethnographic observations will specifically be focused on formal and informal governance interactions. So to that end, I will be monitoring different community discussions related to COI that occur both within Slack as well as in online meetings such as this one. So if you're interested in participating in the ethnographic research, I'd encourage you to attend weekly GovBase Labs meetings that occur every Thursday at 9 p.m. UTC, and any other meetings in which the COI is the topic of conversation. I'll be attending these meetings and recording ethnographic notes based on what I observe. I won't publish anybody's name or contributions unless I receive explicit consent to do so. And then during some COI project meetings, I may also conduct different group exercises. And anybody who wants their participation in these exercises to be included in the ethnographic record, as well as anybody who's participating in interviews, will be asked to complete a consent form. So very importantly, you can still contribute to the COI Pond project without participating in the ethnographic research. And if you wish to be excluded from the ethnographic research, you just have to notify me either through Slack or email. And so on one last note, to help me manage discussions occurring over Slack, I'll be using the Telescope bot, which is a participatory ethnographic tool that enables you as a community to actively participate in the ethnographic data collection. To use the bot, anybody can tag Slack posts that they think are relevant to the research with a Telescope emoji. If the post is relevant, the bot will send a DM to the author of the post requesting permission to archive that post in the ethnographic database. Post authors only need to consent once. After they grant their initial consent, all subsequently tagged posts will be automatically added to the dataset. However, authors will still receive notification every time one of their posts is tagged, and you retain the right to the option to withhold any specific posts from the study. Authors may also withdraw any or all of their posts from the repository at any time by letting me know. Right now, the Slack integration is still being developed for the Telescope bot. So in the interim, I'll be doing some of that DMing manually. So to review anything that I just discussed, or if you want to learn any more about the ethnographic research, you can reference this article that I'm putting into the chat now. That's also been bookmarked to the Slack channels that are being observed by Koi. If you have any questions, just let me know. But I know we're all excited to see the demo that Luke's going to give, so I will pass it off to Luke. Thanks.
Alrighty, thanks for the introduction. My name is Luke. I'm a researcher at Metagov and BlockScience. I'm the technical lead on the Koi Pond project. So let's get started. Can everyone see my screen here?
Yeah, it's good, Luke.
Great. So I'm going to be walking through the systems that power Koi and also giving a demonstration of how you can currently use it. So I'm going to start by breaking down this acronym Koi. So Koi stands for Knowledge Organization Infrastructure. So I'm going to kind of talk about each of those components and what they mean. So first is knowledge. So Koi is concerned with knowledge objects, and we define that as a pretty broad category of things. So it's really anything that we can identify that we want to consider as knowledge. So we have things that you more traditionally consider as sort of digital objects, Slack messages, blog posts, images, videos, web pages, arbitrary files. But we can also refer to more dynamic things like database queries, services, or even function calls. And we're also not restricted to purely digital objects. So we could also refer to physical books, people, and locations. These are all potential knowledge objects that we might be interested in talking about through Koi. Secondly, it's about organization. So this looks like a lot of different things. It looks like communal governance. It looks like automation. It looks like manual curation of knowledge that people are interested in. It looks like the ongoing development and configuration of the Koi system. And this kind of organization is really interested in questions about how do we represent knowledge, what knowledge do we care about observing, and how do different knowledge objects relate to each other. And finally, Koi is infrastructure. So it's a set of interlinked systems enabling the organization of knowledge, which is connected to sensors, which are the inputs to the system, which can observe knowledge objects, and interfaces, which interact with the knowledge that we have stored in the system. So importantly, this is not just about LLMs. LLMs are our current main interface and integration with the Koi system, but we want to be able to support future tools and integrations. And so Koi fundamentally is knowledge infrastructure. It's not a specific product or interface. And so the main way that we deal with knowledge objects is through this protocol we call reference identifiers, or RIDs. So if you look at this kind of drawing down here, an RID is a pointer to a knowledge object, which is that class of things I discussed in the previous slide. So the RID is merely an identifier, which provides the means of referencing any range of knowledge objects that we're interested in talking about. And so the way that we get from this identifier to the knowledge and underlying data itself is by dereferencing it. And so the way that this looks like is we have a dereference function that's associated with each type of RID that we're talking about. And that dereference function will take the identifiers that are stored within the RID and input those into a function which can return the data. So I'm going to break this down a little bit. So at the top here, we have the format of how RIDs are constructed. So you can see that there's three main components here. The first component is our space. This is sort of a wide space in which different types of knowledge objects might exist. So on the right hand here, you see the diagram of what the Slack space looks like. So spaces are going to map to larger containers like platforms, such as Slack. Our second component here is the format. The format refers to objects that would exist inside the space. So in the case of Slack, we have channels, workspaces, messages, and users. And then finally, we have the reference component. And this is the component of the RID which actually is referring to the thing that we're talking about. So in the case of Slack, you can look at this kind of first RID here at the bottom. The first component, the space and the format, comprise the means of reference or the way in which we're referring to a thing. And then the right half of the RID here is the reference itself. And so the structure of this is going to be determined based on the specific means of reference that RID is using. So in the case of Slack, we have three sort of sub-IDs here, which are broken up into the workspace ID, the channel ID, and the message ID. And so when we dereference an object, we have a function that is bound to the means of reference. So the Slack.message has its own function. And then we pass in the right-hand component, the reference, into that function. So it's able to break down this reference component into the necessary IDs that are needed to make a call to the Slack API and retrieve the underlying data that's associated with that knowledge object. Below that, I have two other examples of types of knowledge objects that exist in our system. So we can support Substack posts, and then we sort of have this generic RID handler for web pages, which does a simple get request to a URL. So RIDs form the basis of our system. It's kind of the language that Koi uses to talk about knowledge and to coordinate interactions between different subsystems that Koi is made up of. And so the most kind of important subsystem, which we're going to focus on today, is the graph. So I'm sure many of you are here because you're interested in knowledge graphs. So this is kind of where Koi ties into that. So I'll quickly walk through our kind of implementation of a knowledge graph and the primitives that we use to build relationships between knowledge objects within our system. So the first component we have is an object. So this is any knowledge object excluding the graph relations. So going back to our last slide, it could be a Slack message, a Substack post, a web page, or any other type of knowledge object that we add to the RID system. Next, we have sets. These are unordered groups of objects that can be empty or contain kind of an arbitrary number of objects within them. And then our last primitive is a link. This is a named directed edge or connection between objects and sets that live inside of our graph. And so you'll notice that I said in the first point that objects are any RID objects excluding the graph relations. And the reason for that is that these sets and links are actually objects that have RIDs themselves. And these are things that we can consider knowledge objects because they tell us something about the relationship between knowledge. So to look at an example here, on the right-hand side, we have like kind of a rough diagram of what this sort of graph architecture might look like. So we have this green node here, which has an edge pointing to the set of blue objects. All these blue nodes have their own individual edges to additional sets, which contain additional objects. And so in the case of Slack, this is what that might look like. So we have the set of object types or formats, to use the RID language, which is composed of messages, users, channels, and workspaces. And these are the types of relations that we might want to represent within Slack to represent within the graph the hierarchy that Slack has. So we might want to map a workspace to the set of channels and set of users within that workspace. We might want to map the set of messages within a channel to the channel they're in, and a user to a set of messages that they wrote. So I just kind of pause here to show these are some kind of cool graph views from our current system. These are different queries showing subgraphs of all of our Slack data. So the picture here on the left is the large graph, which shows all the connections. It gets very tangled because you have messages that belong to threads, messages that belong to users, belong to channels, and all of those connections kind of pull them into these groups. On the right-hand side here, you have an isolated view of individual channels, and then the clusters that are kind of surrounding them are threads that live within those channels. On the left-hand side here, we have a sort of collection of all of the individual threads not associated with any channels. And then on the right-hand side here, this is actually my user showing all the messages that I've written and then their relationship to the channels within Slack that they belong to. So I'm going to talk about the current capabilities and then do a quick demo. So the sensors that we currently have active, and sensors are the ways that we observe new knowledge objects into the system. We have these sort of four inputs. So the first one is the live Slack sensor. So this is actually was just turned on right before this call, which is now live in these 4 channels down here: Koi Pond, Board, Attention Econ, and GovBase Labs. So this is receiving all of the events that are sent out every time a message is sent in one of these channels, and those messages are automatically observed into the system and then added to that graph that I just showed you. The second sensor we have is the Slack backfill sensor. This is a kind of tool that we can run once to generate a huge graph and compile all the historical Slack data that we have for Metagov. And then we have a similar sensor integration for Substack and sort of this catch-all websites. So the Substack is able to pull all of the associated Substack posts from Metagov Substack through their API. And the websites, we have sort of a manually curated list of websites of interest that we wanted to enter into the system. So all these sensors provide the system with all the knowledge objects that it uses for a set of interfaces. So the interfaces are the way that we interact with the data, with the knowledge that's in Koi. And so as I talked about in the first slide, Koi is not an LLM, but our main interface to Koi right now is an LLM. So it is an important part of the system. So the interface that we have live right now is the Koi chatbot. So it's powered by an LLM using a retrieval augmented generation system to pull knowledge objects from our Koi knowledge set and use that data to inform its response when talking to users in the Slack. And so that uses a vector store system. So the knowledge objects within Koi, another subsystem is able to take that data, embed it into a vector space, and then use that semantic search capabilities to help the LLM pull down data that's relevant to the conversation that it's having with the user. So to be clear, the data observation from the live Slack sensor is happening in these 4 channels listed here. But you can talk to Koi across any public Metagov channel. And it will be able to, if you look at on the right side here, it will be able to cite all the sources and knowledge that it pulled down. So let's quickly ask it a question. So I'm just in the Koi Pond chat here, and we're going to ask it, tell us about Koi Pond product. And so it's still a very basic system, but it has some capabilities. So if you have a conversation within a thread, if you continue that conversation within the thread, it will retain the context and history of previous chat messages. So it came up with this answer, and we can take a look at the sources it used. So it's taking the Metagov Koi Pond Spotlight post from the Substack. It's taking the Metagov project Koi Pond page, and it's also taking some Slack messages, which were talking about the project. And so to use Koi, you have to specifically mention it using @Koi, even in a thread. And so it's only viewing the messages that you specifically reference, specifically mention the bot in. So I can follow up and ask, how does Luke Miller connect Koi Pond project? And so it's going to kind of remember the context of this conversation and pull down some more messages. So yeah, there we go. I'm leading the development. That's correct. And then we have the sources here. Cool. So yeah, feel free to try this out during or after the call. You can talk to Koi on any channel and hopefully find out some stuff about Metagov. Moving on. So this LLM integration is still pretty new. It has a lot of limitations. So it's not currently using any of the relational graph data that I talked about a few slides back. It has just very basic RAG functionality. So it's just taking the prompt that you give it to it and retrieving related vectors from the vector store, which match to knowledge objects, and using that in its response. And so because of that, and because of the failings that and limitations I think we all know about when talking with LLMs, it can misrepresent people and knowledge. Even if the knowledge is in the system, it might not find it. Even if it finds the right knowledge, it still might make mistakes. So keep that in mind. So yeah, that's kind of the end of the presentation. Before we go, I just want to shout out a few things. So this project is open source. You can check out the repository here. Join the Koi Pond channel if you're interested in talking about this further. There should be a link in the Zoom chat if you're not in the Metagov Slack already. And then one last thing is we're doing a pull down of a bunch of historical Slack data on Friday. So to go back to this slide, we're currently running the Slack sort of live sensor, but we're going to be running the Slack backfill sensor on Friday with everyone's data who wants to opt in. So if you want your historical messages across those 4 channels that we talked about to be part of the Koi knowledge base, then you'll have to opt in by Friday. And I can quickly show how to do that. So go to Slack and click on your profile and scroll down to the bottom. We have this About Me section. And if you hit Edit, this is where you can change your data export consent status. So if you want to opt into this historical data, then make sure you set this to the green dot I consent by Friday at noon. Thank you.
Nice. They're under 30 minutes. Beautiful stuff. We got a lot of questions here. Okay, I think what I'm going to do is I'm going to share my screen. And I'm gonna let's get Koi to put some questions together. So we've got these questions here. I'm collating many questions from the ongoing Metagov seminar. Please put them into a question. So let's see. Let's get Koi going. While I'm doing this, let's see how it works. So you got this little brain going on, and then now we have a response here. Okay, we've got 6 questions here. Don't know if these are actually really that helpful. But let's go with the first one and then I'll kind of backfill from there. So actually let's do a little curation here. How does the Koi tech stack serve the interests of function users compared to other platforms? Who wants to take on that kind of hallucinated question?
I can take a stab at it.
Great.
Go ahead.
I'm not quite sure what Koi means by function users.
Yeah, neither do I.
But so I think the main advantage of Koi here, and this is not something that this is something we're working towards, which is not currently the system is not currently capable of, but is the communal management of this knowledge set. So with a lot of these technologies like LLMs, you have like this huge amount of data that's kind of vacuumed up by OpenAI or other training platforms that is all goes into the system, and there's very little kind of transparency or control over how that data is used. So I think Koi provides a lot of advantages in that we can have kind of very granular control over which knowledge objects that we want to include in the system. And we can do things like manage a specific set of objects that we want to use for a certain purpose. So we could, be able to represent a wide range of consent statuses or kind of intentions for the use of data through communal governance processes.
Okay, we gotta maybe the next follow on to that question, kind of touching on the RID stuff is this format analogous to a type in programming, or is it more flexible? So talk a little bit about RIDs, the idea of type systems and how you're doing referencing in the system.
Yeah, good question. So I think that I would say it's not really analogous to type. So if you're familiar with the URI specification, it's more like a scheme. So in the case of URLs, you have the HTTP at the beginning, which tells your browser what kind of protocol to use to kind of get the data associated with that URL. So RIDs are similar in that sort of the means of reference, those first 2 components, the space and the format, tell the system what function it needs to run in order to retrieve the data, but it doesn't necessarily say anything about what type or form the data will be in when it's retrieved from its source.
Yeah, and I want to kind of jump in here that actually one of the major areas of research, and Luke has been really pushing this ahead, is sort of comparing and contrasting our requirements that gave rise to RIDs in order to build the system with the specified functionality of URIs. And so like what we've observed is that like what we need is something that behaves like a URI, but we also want to equip it with some potentially extra requirements. And so by satisfying URI specs, we get a high degree of interoperability, but by specifying some additional needs, we can just be more specific, whether it's more specific because the organization wants something different, or it's more specific in the sense that the data service or data set that's being referenced, or whatever the kind of knowledge object is, you might need some specificity in order to make sense of it. And that actually really does end up being one of the places where organization specific stuff comes into existence. So like the way that we treat Slack is actually born of the values and preferences of the organization Metagov. We could, in an extreme case, be like, hey, according to the terms of service of Slack, we get to access all this data. But that's not within the aligned with the values of Metagov as an organization. So the way in which we are referencing, accessing, and just making use of data from Slack is bound by the policies that we are implementing via the software. And the patterns which we can support in our COI are different from the patterns that are supported in other software because we've designed it with different requirements in mind.
We've got someone already asking a question in Koi Pond. I want to kind of do an unprecedented move here, but I think it's a good question. Why does Koi start with Slack and Substack and not some open source projects? There's an answer here from Koi that I'll post in the chat, but I'm curious to see how the answer that Koi gives aligns with the answer that the panelist gives.
I'm going to take a cut, but I think we should actually all answer this question maybe. So my opinion is that the development of a technology like Koi is not really a purely academic project. It's actually operational. We have pain points where there's lots of information. We're trying to find it. We're trying to make sense of it. And what ends up happening is that the lowest hanging fruit comes first, and it becomes like, hey, on a day-to-day basis, we are mostly interacting via Slack, and Slack is already very chat-based. And so it was a natural location for these interactions. And the Substacks are the things that are the most immediately necessary information to distribute from the perspective of this organization, because it contains information about projects. And it's Substack as well as the website, which project information, information about policies and rules within the org. And so you could just look at it from this like really honestly boring perspective that like that's the interface people are using. That's the most easily accessible data that they actually need and want and are currently benefiting from getting this way. Iteratively extending to other stuff very much on the roadmap, but start with something real, make it work, try to make it better.
Any of the other panelists want to jump in?
Just to say that we often think about very formal interactions as being superior to day-to-day, more conversational interactions and questioning and decision-making kind of on the move. And so one thing we're interested in this project is how those informal governance interactions, which don't even feel like governance, are actually steering an organization, and whether we can have technologies that are responsive to that. So the more ethnographic components of this work, there's Brooke's PhD, Kelsey's doing some work on this on the BlockScience side, and I'm kind of across the project in general is concerned with those types of questions as well. David?
I was just going to say that the purpose here in my mind is to be a tool for an organization. This, I think, Zargham said it to some extent. If a GitHub repos are the be all and end all of your organization, then by all means, that's the first sort of sensor that you want to build out. BlockScience publishes a bunch of papers, so we brought in a bunch of papers, and Metagov talks a lot. So it's the chat interfaces that are most interesting here.
Well, I'll jump in at the end here. I agree with everything that was said. I want to take it from the technical side, though. I think one of the key advantages of Koi and the RID system is that we're really not dependent on any of these platforms. So in this case, Substack and Slack do not form like a core part of our infrastructure. They're merely a source for a potential set of knowledge objects. And the sensors that we build to interface with those platforms, and the integrations we build to do kind of automatic observation, those are all open source. And so anyone can kind of take advantage of that. And at the same time, we want to make it easier for future communities that use Koi to build their own sensors for platforms that have knowledge they're interested in observing that don't exist already. So that would definitely include open source stuff too.
Cool, great. Thank you. Okay, there's like I'm gonna see if I can try to like compound these two things together. There's sort of like two questions around like the kind of resonance that this project has with the semantic web. I know RFDs also get brought up a lot with this. And I'm curious like how, if at all, I mean, the question is like whether or not it's kind of an accurate or inaccurate analogy to make between this project and the kind of semantic web. And alongside that, I'm curious if you have any thoughts on ways in which the kind of latent semantic undersurface of this might be able to kind of malleably represent itself in a way that actually starts to have an influence on the way that people are interacting with each other in their digital environments. Currently, it seems like the way that the system is set up, it's like, I mean, every time it posts, I feel like I'm just getting spammed with like 20 links. And like, it's also incredibly verbose, and it goes so quick, like in a way that like a human would never actually type. Like these kinds of like frictions that are kind of built into systems that are otherwise automated in order to kind of give it a sense of like not humanity, but a sense of like to kind of expand the interaction time space. I'm just curious if you could sort of talk about how the system might actually be more adeptly situated within its environment in a way so that it becomes a kind of interlocutor or collaborator, a kind of agentic force within an organization rather than just a kind of butler or server. And maybe you can try to make a connection with that question and this idea of like the semantic web. It's a little bit abstract, but you all are very smart, so I'm curious to see where you take it.
I want to react to kind of. Oh, go ahead, Ellie.
No, I was also just going to say for the more technically minded people on our team, add to that whether the way that we're using it and the kinds of responses it's given is also just a function of it being plugged into ChatGPT at the moment, and whether other more localized AIs might give us a different kind of interaction that feels more homely for us.
Yeah, so the thing I was going to react to was your sort of comment about it being not just a butler. I think it's important to differentiate there's sort of a functional architecture going on with different components filling different functions. And the thing that's just like a butler is the LLM. It's sort of orchestrating. We're not trying to leverage the large language model, the thing that hallucinates, to do kind of complex or specific tasks. We're actually imagining, and in some cases implementing, other services that do the specific tasks, and that it just needs to know what things to invoke. So one of the practical use cases that we've discussed with you, Senti, as well, is the support for onboarding, and whether we want to have a specific kind of bot that helps match people with potential mentors, or like those would be more traditional microservices, which would have data available to them. They would have specific rules. Even if you accessed them by way of a conversational interface in Slack, it's really just the ability of the chat interface to identify what you're looking for, potentially through an RID pointer to it, invoke it, get its response, and return it to you. Some of the verbosity of what we have right now comes from the fact that we predominantly have a chatbot and a bunch of documents and messages, and that a big part of what we're doing with the battery of links is just making sure that we're limiting our hallucinations and making sure we're understanding whether it's answering in a way consistent with the materials versus making stuff up. And this is also part of the earliness of the project. Another piece of the research that hasn't been presented here, but I think it's worth alluding to, is the kind of requirements engineering framework side of these kinds of systems. And so at BlockScience, we have a pilot called Blocks of Docs, where we actually characterize specific requirements around blocks of text and sort of working on asserting the extent to which LLMs can satisfy them, or which things that are returned by LLMs can be verified to satisfy them. And the important thing about that capability is it ultimately provides us some of the governance surface of these tools. If we don't want it to be so verbose, we need a way of saying and technically infrastructuring it to be less verbose. Right now, we have a lot of what I'll call default behavior, in the sense that we just got it up and running, we're inviting people to participate in its governance, and we actually rather intentionally avoided making too many decisions about how it should behave, because we wanted to present what we had, announce it, solicit feedback, and engage the broader community in deciding, like, how do we want it to behave? What data should it have access to? What kind of data services should be in this mesh? And ultimately, the RID system is there to help make sure that we can identify those things and assert rules about them, and ultimately both deliver an infrastructure, a knowledge organization infrastructure to this organization, and ensure that the governance surface of it is kind of exposed to the people in the community. And that creates some UX challenges. Long run, like you can't totally govern a thing if you don't spend some time making sense of it, learning about it. And so we're trying really hard to strike the balance between technically building new capabilities, sharing those capabilities, and engaging this broader community in like how best to make use of them. And so I'm gonna stop there. I realized that was a little bit long.
Thanks, Zargham. Lee wants to jump in on the semantic web point because they're a nerd. That's their words. And then I'm going to pass it over to Gregory. Sorry, I'm doing that right. George, sorry, CS, who's going to ask a question about argumentation theory. Lee.
Yeah. So read the semantic web stuff. I noticed that question coming in of a lot of this seems very resonant to semantic web things. Anyone can correct me here because I'm semi-new to Koi. But the thing that's really exciting to me about Koi related to semantic web is that the semantic web asks us to have basically an ontology for the entire internet that is interpretable to everyone and machines. And the problem with that is getting everyone to coordinate and agree on your universal semantic ontology, which is effortful and terrible and clearly still hasn't happened, even though we've been talking about it for a while. But the thing that's interesting and exciting about Koi is it allows a community to kind of define your own semantic understanding of your own artifacts. And then in addition, individuals can add their own additions to this and their context to it. As a result, it's both responding to the community and the individuals in the community, as well as structured around a community's needs and directions. The thing that's also exciting about this is because it has that flexibility for like individual and community action, you can also link your community's Koi with somebody else's Koi very easily, right? So it's like, oh, here's our context. And if we draw a semantic link to your context and your frame or your words that you're using, then we can almost like walk across different community knowledge bases in a way that doesn't require us to have a universal understanding of the internet, but instead we can just kind of traverse this semantic graph, which eventually, like there will be maybe communities that are more isolated than other communities, but eventually it can add this communicability and machine readability without needing everyone to agree, which I think is really cool. And people can technically correct me if I am wrong.
I think that was a really good way of putting it. I just wanted to kind of add some more technical background. I think that's a great point that like the thing that Koi really provides is the ability for communities to like hone down on what exactly their community benefits from. And that being said, we still want some interoperability to enable the type of communication between communities or between Koi instances that you mentioned. But that interoperability is not required at a global scale. And so, I mean, to kind of enable that, which is why we're like developing this as an open source project, and as kind of the first stage, as something that Metagov and BlockScience are collaboratively working on. to kind of develop standards that can be shared between them. But it allows each community to sort of pick and choose which types of knowledge objects they care about, which types of knowledge objects they want to build integrations for or implement existing integrations. And on the graph side, which that kind of ties to which knowledge objects you're talking about. So a certain type of semantic relationship might go with, for example, Slack objects. So in the graph I showed, there's certain relationships between channels and messages and users, which we're probably going to want to share the same syntax if two groups are talking about Slack. But it's designed to be more extensible in that global interoperability requires very like disciplined standards development and governing bodies to deal with that. So we're sort of shrinking it down to a much more local scale.
All right, nice. Let's move on to this question about argumentation theory from George.
Hello, thank you for the presentation. I'm not sure if anyone but Sant and Val were on the previous week's seminar, but Matthew there presented something similar where they split knowledge into arguments, inquiries, experiments, and some other. Do you have any taxonomy of knowledge? Do you use any epistemical analysis to figure out what is just said and or how it's valid? Can't put the question better right now.
Thanks. Who wants to take that? David, I see you came off mute.
Yeah, I can take a crack at it if nobody else wants to. I think the idea here is to sort of start from a naive position that there's no like as little presupposed as possible, and then build from there. So to the extent that it would be useful to have sort of a categorization of knowledge, it can be developed. There's nothing. In fact, that was one of the things that you know, one of the use cases that RIDs was developed to handle. But there isn't one inherent in the system. I don't know if that answers, but
Thank you.
I think that it also refers back to the semantic web. There in order for the semantic web technologies to work well, a lot of stuff has to be known ahead of time. In fact, that's in my experience, it's been one of the difficulties to make those systems work, is to sort of amass all of the relationships and structures that need to be amassed before you can use the technology. The hope here is that some of that, the effort involved in doing that can be automated away to some of these systems.
There's a little bit of discussion in the chat around interorganizational COI communication. It's kind of framed in terms of like bot battles, but I mean, I know Orion Reed, who has done some work at BlockScience, has set up a kind of a TL draw prototype where COIs between organizations can actually interface with each other. I was wondering if maybe you could kind of gesture a little bit in that direction of like, we've been talking a lot about what COI means for an knowledge institution or knowledge organization, but like, how do you see this kind of in a networked sense? And also maybe to kind of spice up the question a little bit, like, you know, I mean, Dana's pointing towards like bot battles, but like, what are some of the like unintended side effects or consequences of this that we should be thinking about in terms of having knowledge organizations interfacing with each other?
We can take a stab at this one. So interoperability. So I also just want to be clear about the current state of the system. So we don't currently have any information sharing between BlockScience and Metagov. This is part of the research that we're doing in spinning up two of these instances. but RIDs are a big part of that. So one of the advantages of them, which I didn't really get to in the presentation, is that because we're not worried about sort of keeping like a ground truth or storing all this knowledge we're caring about in a single place, we're just pointing to where it lives kind of in the world. It becomes much easier to share common reference points to what we're talking about. So let's say, for example, BlockScience wants to share a set of RIDs that comprise a subject that they've curated. They could just send that set to Metagov, or even send the RID of that set. Metagov could dereference that once it's entered into their COI and retrieve the knowledge objects that are within that set. And Metagov may be able to directly dereference all of those knowledge objects on their side without having to go through BlockScience. Obviously, there's going to be cases where organizations are going to represent knowledge which is more siloed or private, or like in the Metagov Slack, which is not technically a public space but has a lot of people in it. And that's kind of a case where we're going to want to have kind of infrastructure to allow Metagov to ask BlockScience for access to an RID pointing to something that they can't access yet. But that's kind of the direction that we're thinking about.
Ali.
Yeah, I think just to double click on that confidentiality issue, I think that's something that's super interesting in this project, is the extent to which you can partition off knowledge objects or sets of knowledge so that they're not accessible by the LLM or another organization or whatever it might be, something we're very interested in. But I think the bigger potential here is really for organizations who we might call civil society or networks or DAOs or whatever, to be able to share the things that might enhance the capacity of other organizations, so that everybody isn't out there duplicating things, particularly organizations that don't have the kind of scalability or the kind of efficiencies of large firms. So how do we make small organizations or networks like Metagov more not really functional, but I suppose competitive is also not quite the word, but just enhance the capabilities in a networked fashion.
Great, thank you. There's some technical questions in the chat. They're getting answered async. I want to remind everyone that you can ask questions to Koi in the Metagov Slack at Koi Pond.
Can I share the list of what we curated and invite people, maybe talk about possibly helping decide?
Yes, please. That's where I'm headed. What can people do who are on this call?
Great. Let me first bump to Lee and the company about how do we want people to share? Do we want them to write directly into the Google Doc we have, or do we want to take an intake form? I can share what we have to date, but I just wanted to make sure I'm not directing people in the wrong way.
Well, I'll jump in. I while we were on the chat, I made another form for people that's the same as the one that we have, but like for people to suggest, because the one that we curated is more just COI related objects. So I've created another doc here that I can share where people can suggest other sorts of documents that they're happy to be, or that they'd like to see put up into COI.
Great. So, well, I'm just going to do a quick overview of what's in there right now. So as a group, we just kind of like speed ran through and figured out.
Can you control plus that maybe 2 times? It's a little hard to see.
Cool. So we made a first draft of COI specific knowledge objects that we wanted to index, and then got them out there. And so what you'll see is a couple Slack channels that were the originally targeted ones here. A bunch of objects that we called core, which are basically blogs and GitHub repos that were most directly related to this work itself. And actually, one of the most fun parts about this was recognizing how much of our existing work was, quote, predecessor. So we talked a bit about the telescope bot, which this is the paper about the telescope bot that Ellie and Luke and I, along with many other folks at Metagov, had worked on. Josh Tan, who's I believe also here, feeds into this research, as well as some work on the BlockScience side about what is computer-aided governance and how do we think about governance in terms of its sense-making and decision-making processes that fed into this. there's actually just an incredible mix. If you just look at the graph of authors and objects that in this list, you can see kind of gives you a flavor of where this comes from. But the point here is not for this to be Koi only knows about Koi. This was here to bootstrap. The goal in the long term is that Metagov itself needs to decide what belongs in the knowledge base. And that could mean a bunch of papers by people who are community members. It could be a bunch of papers that we just refer to or cite frequently. I love citing back to some work from Suchman related to, I learned about this from Ellie and her group, so shouldn't talk about it too much, let her talk about it. But what I'm getting at here, sorry I'm rambling so much, is that what we need next is a process to solicit contributions of what should be indexed and possibly some annotation. So even my initial heuristic here of core predecessor application just says, hey, this is the core Koi work. This is stuff that we learned in the past and built on versus stuff that uses Koi, which is obviously the minority since this is the newest thing. And where we got to go with this is decide both what should be included in these databases and how it should be annotated, possibly how it should be prioritized. So I'll stop there, but this is the stuff that's in there now. It's not too long, but it's all pretty relevant to Koi itself.
Okay, great. We have 1 minute left. Let's go ahead and someone use the link that Brooke shared in the chat to engage with what Zargham was just sharing. We always like to give our speakers a round of applause. For some reason, we've been doing this for 3 years. It seems kind of weird, but we do it. So come off camera or come on camera if you like, unmute, and on 3, 2, 1, let's give a big round of applause, a cheers for our speakers. 3, 2, 1.
I want a second round of applause for Ellie and Brooke because they're in Australia.
Yes, let's go. 2 applause.
2 a.m.
Well, an applause to all of you for being here. Nice to see so many people here. I want to point out that we have another seminar happening next week. It's also going to be very good. It's by Denise Akara. It's called Experimental Governance Sandboxes and LLM Agent-Based Simulations. You definitely do not want to miss that one. Information is there in the chat. So see you next week. I'm going to close out the recording and then I'll keep this open for a little bit if anyone wants to stay and chat longer. Where's the stop recording?